Hello everybody. I would like to talk today about the contact tracing Bluetooth specification as done by Apple and Google. But first, what is contact tracing? Let's assume you are on a show with lots of booths, visitors, and what we have here is usually that you serve business cards, you are asked for getting business cards, and you're also collecting business cards. So that's what you do. You provide your business cards, not only once usually, sometimes people beg about them, and you're also collecting business cards. So this is what is kind of a chain. The red bars is contacts you have with whatever person. So just assume you change business cards when you're in close contact and you mark them, and now you mark them with an additional date on it. There are islands which are not connected. This guy on the bottom left is probably not really interesting in selling. Okay, let's use the list you got and start thinking about infections. Okay, you got that list on the left side with your contacts. On May 1st, you're told that Hendrik is tested positive. What happens? You go back 14 days in that window and check if Hendrik is in the list. You see, Hendrik is in the list. So you are possibly infected. Probably have to go to quarantine. Okay, let's assume another case. On May 1st again, you're told that Laura is tested positive. So again, you open up that window. Laura is not in your list. You had contact on April 10th, but that's out of the window. So that's called no problem. So now replace yourself with a smartphone, your business card with a Bluetooth broadcast, and the list will manage within a smartphone service, and you're almost there. Okay, let's get a little bit more formal. We have four major things which are necessary. First thing is your smartphone has to broadcast your contact information. This is necessary for others being able to add you to the list later on. So that's something you don't need, but others need. On the other side, you're collecting a list of contacts with timestamps. So now you see yourself need the broadcast from others. And that's to be able to later on match if some of the others were infected and you had contact with them. And then uploading your positive test to a central server. So whenever you are tested and now you know you have something in your body, you have or should upload that to a central server so others can match. If you don't say you're infected, the whole thing doesn't work. And of course, you have to match a positive list with your contacts. That's kind of the final thing you would like to do. You want to get informed if you possibly have an infection, and that's kind of the final step. But we have permissions for that. There is a permission. Really, the OS is asking for you for a permission if you want to broadcast and collect the list. This is one permission as far as I know. But there is a second permission. It's not really a permission. It's kind of the app is deciding that. Would you like to upload your positive test to a central server or not? Well, it's essentially an active action you take. You kind of press a button to do so. And I haven't seen an app, but I'm assuming that's happening. And the last thing is, if you got a list from the server about uh, kind of contact information of infected people, then the OS will do the match and you will get asked if you really want to do the match. Kind of, would you like to be informed of a possible infection? These are all permissions you have in the app. So what about privacy, location tracking, and so on? Well, what I have to say, maybe the force be with you, but in that case, it's really with Google and Apple. So let's check their solution to restrict data collection and tracking. Kind of interesting. Those collecting the most data would like to avoid that governments are taking the data. Anyhow, maybe it's a good thing to really create trust in people because very important is that many people are using that afterwards. Well, there is a small module on cryptography, but believe me, it's just a very small amount. We need hashes. Hashes are non-reversible functions, generate fixed size output regardless of the input size. Probably make this a little bit bigger. So what you get here, you have some random text, and with a hash, you create a fixed size output number. This is pretty much like a UID or something like that. 128-bit usually. This is just hex numbers for you. This is created out of that, and there is no way to get the left side back from the right side. So that's what it's called a non-reversible function. And if the text is longer, it doesn't matter because the hash size will still be the same. We will use that on generation of the keys later on. So hashes are non-reversible. If you get the hash, you don't know what was the input. The only thing you know, if you have the same input, it will generate the same hash again. Okay, now let's talk about a couple terms which are used within the contact tracing specification. We got the tracing key. This is generated once per device. Now, as once every day, we take the date, add the tracing key, kind of a plus operation, string concatenate or whatsoever. Use the hash function, which is used before, and what you get is a daily tracing key. So that's a key which is new every day. And again, with that key, you can't go back to this one. So you don't know if the tracing key was from November or from which device. There is no chance. And a second level, we do almost the same now with the time information of the day, but the time is split in 96 pieces of a day. Kind of you count the number of quarter of an hours and add the number of so kind of 30 minutes past or 30 minutes past midnight. It's kind of number 2 or number 1, however you count. Add that to the daily tracing key. Use the hash function and create a rolling proximity identifier. Again, generated once every 15 minutes. And this gets broadcasted roughly about every 250 milliseconds. So now, you can switch it back. Let's see what this means on a timeline. You start with tracing key in April 27, then you create a hash right after midnight at the first one with the daily tracing key. And with the daily tracing key, also right away, you create a hash with the number 0 time slot and create a rolling proximity identifier. And this gets broadcasted into the air. So that's what other people see from you, essentially. Okay, 15 minutes over, the next one will be generated. So you use the DTK number 1, add 1 because of the kind of the second slot of the 15 minutes of day, create the second rolling proximity identifier. And that's done for 96 slots because the day is split in 96 quarter of an hour slots. And then you do the same on the next day and you assume it's working exactly the same way. And then you do the same way on April 29th and so on. Okay, remember Bluetooth low energy broadcast is every 250 milliseconds. Okay, receiving schema is pretty simple. The search is done roughly every 5 minutes. The smartphone is kind of checking what's nearby and stores every received rolling proximity identifier together with the proximity and time for later use. So it's simply just open your eyes every 5 minutes. Roughly, it doesn't have to be 5 minutes, but that would be kind of a normal thing. See if somebody is around you, and then you close it. It's probably the idea is you've passed somebody only for 1 or 2 minutes. It's not a big deal. Okay, and of course, power consumption is a really big topic. You don't want to be sucked out the battery of the smartphone. Okay, well, I can probably switch back. What happens on a positive COVID-19 test? So assume again you're May 15, you receive a positive test result. Okay, now it's up to you. You can decide if you want to send your DTK to the public server. If you say yes, um, the daily tracing keys from the last 14 days would be sent to the cloud. This set of 40-day tracing keys is called a diagnosis key. So it's kind of packed together to one diagnosis key, which is a list of daily tracing keys from the last roughly 14 days, probably change them up. What you see here is a full service of the probably government app. So that's not service of the contact tracing specification of Google and Apple. That's not in their OS. That's something you can do if you want. Of course, you will have to provide permission to get those DTKs. I haven't put that in that list here. If you say no, nothing happens. So if you don't want to do that, you're probably not forced to do that. Not clear how the apps would look like. Okay, let's go back to the daily finding. If you do daily, you have to check the contacts. So what happens is every day the app is loading the DTKs from the cloud server. So kind of that diagnostic keys, which are in a sense a list of daily tracing keys, which people which have been infected by that time or possibly infected by that time. So now what's happened? You have to create out of those per person 14 daily tracing keys. You have to create all the 92 rolling proximity identifiers which are used for those and find matches of those rolling proximity identifiers you have in your list. If there is a match found and you see the color again, the blue color tells you um, that this is part of the OS. So whoever provides you the app with, this is done in the OS of Apple and Google. And if they found a match, they report a number of contacts to the app. And then the app can get a list of contact details. This is where you get asked again from the OS to give permission. So only if you give permission to the app to do that, you will be provided with more details like time duration and what time it was, essentially. Obviously no person because they don't know any person. And then the app can show you details, so you have a chance to say, okay, is there a chance that I'm infected? Should I be a little bit more uh, avoiding contacts and so on. Let's go a little bit more deep into that black box here and into that blue box here. Just make an assumption what that means for calculations. Well, currently we have example daily calculation for US daily new cases, about 20,000 new cases in the US. So with a 60% app usage of people, so we get 12,000 reports per day. It's just an assumption. People say 16% is kind of necessary. If you multiply that by 16 days, we get out of that roughly 170,000 DTKs, daily tracing keys. With 69 time slots per day, we get 16 million rolling proximity identifiers. And now assume you have collected 500 different RPIs, which is probably a lot. You have to stay close to somebody in 5, so maybe 100 is more fair or not clear. But choose a little bit of higher number. Kind of that's a corner case, I'm assuming. You have to do 8 billion checks. Well, assume UK with 4,000 use cases, you have to do 1.5 million checks every day. That's creating hashes and compare, which should be doable for smartphones. In Germany, for example, at today 600 and which means 250 million checks. Well, it's very likely because of that numbers that the area is reduced by governments, like Great Britain is doing now, that you have to provide in your app the first digits of the zip. I think they put the half zip code in there, which probably means you get only informed about your area to reduce the number of cases you have to match, which would probably make sense. It's not good for long traveling, but most people don't do a really long traveling, uh, especially not now. Uh, but anyhow, back to Great Britain, they probably don't use the this API as far as I know, um, yet. Not clear. Okay, thank you very much for watching. I hope you get a little bit and see you back soon.